Is the last full chapter, so December 5th will be the last chapter test before the final. We will have a little bit of stuff to kind of piece in before we get to the final because I honestly don't have the final yet. So if there's anything that we either approach differently than they wanted us to approach or that we kind of went, oh, we don't need this, but we might have to piece those pieces in just because I don't get to write the final. So after this chapter test on the 5th, we will have a little bit more to do. We'll have to review some system stuff, and then there's usually 1 or 2 pieces that we have to kind of work in or reword based off how IU does the final. But when we get there, I will give you as much details as I can when I get them. I haven't seen it yet, so I genuinely have no idea. We should get it within the next 2 weeks. They told us we should have it before Thanksgiving break, but we'll see.
Why is homeworks for 5.2 and 5.3 in the same box?
5.2 and 5.3 are in the same box because the book divides up exponentials in a bizarre way. They'll do like numbers with the power of x separately than e to the power of x, even though they all get treated the same kind of way. So we took fewer numbers from both of them and just kind of smushed together to push them together because logically they go together pretty close. We will. And if we need to trade them in separately, totally fine. Like, it's a vibe. We're going to start by talking about functions and one-to-one functions because we're going to be working with inverses. We're going to be working with, switching our x's and y's. That means in order for us to have an inverse, function has to be one-to-one. So when we have a function that's one-to-one, what that means is each x goes to only one y. That's our rule for function. With our graphs, we're testing that with our vertical line test. With our one-to-one functions, what that is that each y also comes from only one x or goes to only one y. Goes to only one x. So our x's go to one place and our y's go to one place. One-to-one means I don't have an x of 2 that could give me either 4 or negative 4. 3 or negative 3. I don't have a plus or minus situation going on. For the most part, the way we check for graphs for one-to-one is with our vertical line test and then our horizontal line test, which is going to require my super duper high-tech, ultra fancy math tool. Steak. So the first thing we're going to look at is how to decide if a function is one-to-one. So we're going to look at some sets of points. This is the only set of points we're going to have. I'm not going to make you write down the billions of sets of points. And we're going to look at this graph and this equation so we can see if these are functions and if they are one-to-one functions. So if it's a function, each x goes to only one y. So when we're looking at like a list of points, we're looking to see if there's any repeats in the x's. So we have 1, negative 3, 2, 5, negative 6, 1, 4, 4, and 5, 0. We don't need to plot it up. We don't need to draw a picture. We just say, are there any repeat values in my x's? Not in this first one. We've got a 1, and then I've got a 2, and then I've got negative 6, 4, and 5. I did not say the same number more than once. No repeats there. So this one is a function. Yes, dear. Oh, I can put it back there in just a second. When we're wanting to see if this is a one-to-one function, we also want to see if there's any repeats in the y's. So we have our negative 3, 5, 1, 4, and 0. Did we have any repeats there? No. So this is also a one-to-one function. And you're going to say 1-1. You can write out 1, 2, 1. You can put the semicolon. Don't put 1, numeral 2, 1. It's not 121. So this first list of points is a one-to-one function. I've had a request to go back to the side with all the words. So I'm going to put it back there for just a second. We'll come back to this one here in just a second. So I had a request for this page for a little bit longer. Yeah, I'll make your best. Okay, so now let's look at this second one, the second list of points here. We've got 0, 3, negative 2, 4, 8, 1, negative 4, 3, and 5, 0. So first thing we're going to need to do is we're going to check and see if this is a function. Does each x go to only one y? So we're looking to see if there's any repeats in our x's. Do I have 0 going to 3 and 0 going to negative 4? That would be 2 different points on the same vertical line. So we check and see if there's any repeats in my x's. 0, negative 2, 8, negative 4, and 5. Is this a function? Yes. This is definitely a function. Each x goes to only one y. So I don't have any repeats in my x's. That's passing our vertical line test. If I was to plot this up, each x would only go to one line. I would never have more than one dot on my vertical line. For our one-to-one function, that's when we're checking our horizontal line test. I want to make sure each x comes from only one y. Each y goes to only one x. It goes the other direction as well. So one-to-one functions have to also have no repeats in the y's. So we have our 3, 4, 1, 3, 0. What do we think? Is this one a one-to-one function? No. Why not? Which one's our problem?
3.
The 3. Because negative 4 comes with the 3 and our 0 comes with the 3. Because we have a repeat in our y's. What that means is we would have 2 points on the same horizontal line. Our horizontal line test would fail. It's a function, totally fine. It is not a one-to-one function. It can be a function and not be a one-to-one function. It cannot be a one-to-one function if it is not also a function. So if it fails the function test, you do not have to go any further. When we're looking at our graphs, we're going to think about our super duper fancy schmancy mathematical tool, the steek. And we're going to do, even when we have funky, weird graphs, we're going to do our vertical line test to check and see if it's a function first. And then we're going to do our horizontal line test to see if it is a one-to-one function. So first things first on this number 3 here, is this a function? Yeah, totally cool. Absolutely passes our vertical line test. No issues. So this one is a function. That's our vertical line test. Then to check and see if it is a one-to-one function, we do our horizontal line test. Is this going to pass our horizontal line test? No. I mean, it does down here, but once we hit our function, it is crazy. As soon as we get to our function, we're instantly crossing our horizontal line more than one time. Cross this twice here, cross this twice here. Even if I come up here, it's still going to cross twice. So it just takes one failure for it to be a no. So this is not a one-to-one function. It fails the horizontal line test. So this one is not one-to-one. It fails our horizontal line test by hitting more than one time in a number of different places. What do we think about this equation here? F of x equals x squared plus 3. going to look like? It's a parabola. X squared plus 3 going to look like that, right? Even degree function, those arrows going up in the same direction. So if nothing else, I know it's an even degree, positive leading coefficient. They're both floating up. Is this a function? Yeah, we get a big old clue right here with the f of x notation, because if we write it like this, that means it's a function. So definitely a function. Different color. So from this and from our vertical line test, we know it's a function. Is this a one-to-one function? Nope. This fails our horizontal line test. So any even degree function is going to not be a one-to-one function. This fails our horizontal line test. So odd degreed functions can sometimes be one-to-one functions. Even degreed functions can, as a whole, not be one-to-one. So when it comes time for us to be using our one-to-one functions to make inverses, we're going to have to do a little domain restriction to make it have a function as an inverse. It's sometimes really hard to tell when we're looking at these equations. So when we're looking at equations, we have another way that we can kind of think about how to tell if something is or is not a function without having to like sketch it out. And that would be if we have an equation and if we have a function that is only increasing or only decreasing. It never changes from going up to going back down. It never turns like that. It will be one-to-one. It is only increasing or only decreasing. So looking at a couple of equations here. We have ourselves a linear equation and we have ourselves a rational. What do we think about this linear equation? Is this going to be one-to-one? Yeah. This one, if we think about this being an mx plus b, if we ever have an mx plus b situation, and we have any kind of slope, as long as our slope is not 0, where we have a horizontal line, we will have a slope, which means it will be decreasing or increasing. Since this one has our slope of -2, that means this guy is decreasing. It's getting smaller, which I think I just spelled decreasing wrong, the whole time. Every single point on this line is getting lower as we go from left to right. It would look kind of like this. It is constantly decreasing. Since it is constantly decreasing, that means this is one-to-one. If it is always decreasing or always increasing, it is one-to-one. got this rational. What do these things look like? Huh? Yeah, they're kind of R-shaped. So we've got our like this guy and this guy. These guys that we were just kind of working with. And like, I can find my asymptote. We have a discontinuity. Our asymptote's going to happen when our denominator is 0. So at 2, we'd have 1. Is this increasing or decreasing?
Wouldn't it be both?
So we read from left to right. So we are increasing here on this segment. What about on this one? Increasing. Because we read from left to right. So this is getting higher, and this one is getting higher. That's a plus. Even if they were going the opposite direction. So maybe if I had one of those reflection ones where it looks kind of like this. I'm dragging purple this time. So now this one is, when going from left to right, we are decreasing, but this one is also decreasing. And I don't have a gabillion arrows up here. Ooh. So no matter which side these are on, these rational functions are always increasing or decreasing. The only place we're going to run into problems is where our denominator equals 0, and we have that as an asymptote anyway. So rational functions are always going to be just increasing or just decreasing unless we wind up with any of those middle kind of funky pieces, like the weird like S-curve in the middle. Mm-hmm. Those ones we run into problems with being function or being one-to-one. When we have a regular one-to-one function with horizontal asymptotes, not slant, but horizontal asymptotes, we are good to go. If we have slant asymptotes or more than one vertical asymptote, that's when we're going to run into problems with one-to-one. So basic guys are, in fact, one-to-one. We are not going to have tons and tons and tons of rationals that we're working with inverses with, because I'm going to put up our first page that we're going to talk about tomorrow because we have 4 minutes left. We're not going to work through any examples, but we are going to start talking about inverses, how to find inverses, how to test inverses, and the domain and range of inverses. So I'm going to have this be up here. This is going to be our last slide for the day. I want to make sure we have plenty of time to write.
Since it's the last 4 minutes, can I just get my test back and finish it? It's just one question. I'd like 2 questions.
Yeah, because you get extra time anyway because you're not my new somewhere. So you get extra time. So if you need to come back during fifth, you can do that. All the stuff we're going to do with inverses you have done before in Algebra 2. We're going to be talking domain and range a little bit more in detail than we did in Algebra 2, but you have done inverses before.